Alright, here's 7-2. I'm going to do example 1 on this video, example 2 on the next video. And all of the things that I'm using come from 7-1 notes. So any of the formulas, if you want to know where they came from, we use them on the 7-1 notes. So in 1a we had tangent A equals secant A over cosecant A. And so the tangent is the same as the sine of A over the cosine of A. And over here, the secant is the same as 1 over the cosine of A. The cosecant is the same as 1 over the sine of A. Now, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So, over here we have the sine of A over the cosine of A equals 1 over the cosine of A, and then times the sine of A over 1. So when I multiply these together, on the right side we didn't change anything. On this side we wind up with the sine of A over the cosine of A. Now the thing I like about these problems is as long as you follow the formulas that we have, eventually we're going to get to the point where we have the exact same thing on the left side and the right side, which is what we're looking for. In 1b we had secant x minus tangent x equals 1 minus sine x over cosine x. Well, the secant of x is the same as 1 over the cosine, and the tangent is the same as sine over cosine. I'm not changing anything on the right side because right now all we have is sines and cosines already. On this side, on the left side, we have cosine of x as our common denominator. So all we have to do is subtract the top, and the cosine of x stays on the bottom. And if you notice, the left side matches the right side already, so we're finished. Alright, letter C has secant x cosecant x equals tangent x plus cotangent x. So that's 1 over the cosine and 1 over the sine. Tangent is equal to sine over cosine plus cosine over sine. Now on the left side, we can just put those two fractions together because we have multiplication. On this side, on the right side, we need to get a common denominator. So the first one is missing a sine, and the second one is missing a cosine. So what I have here is sine squared x plus cosine squared x over cosine x sine x. This is our common denominator. And the sine squared plus the cosine squared is one of our Pythagorean identities, which turns out to be 1. Since the left side matches the right side, we are done with that problem. Alright, in letter D, I decided to, since they already are in sines and cosines, I decided to cross multiply to see what happens. So cosine y times cosine y on the left side, and 1 plus sine y times 1 minus sine y on the right. So on the left, when we multiply them together, we get cosine squared y. And on the right side, when I FOIL, I got 1 minus sine y plus sine y minus sine squared y. And the sine y and the negative sine y cancels out, so we have cosine squared y equals 1 minus sine squared y. Well, since 1 is equal to sine squared plus cosine squared, we put in the sine squared plus cosine squared, and we still have our minus sine squared here. So the sine squared and the minus sine squared cancel, and so we are left with cosine squared y equals cosine squared y. Alright, last one for this video, letter E. We have sine theta, cosine theta, tangent theta I'm going to change into sine theta over cosine theta, plus cosine squared theta equals 1. Well, the cosine and the cosine cancels out, and so we're left with sine squared theta, because sine times sine is sine squared, plus cosine squared theta equals 1. And since these add up to be 1, we have 1 equals 1. And that is all for this problem in this video.